Hello, everyone. Okay, thanks for coming out, especially in this very nice weather. Thanks for coming all the way. So my name is Lenz. I am a developer at CMIC. I am also a GDG organizer, FlutterMTL organizer, part of the amazing team that's bringing you these events monthly. Along with, you've met the team. Today, we'll be discussing building custom render objects in Flutter. So the agenda would look something like this. And you guys can hear me all right, right? Awesome. The agenda looks something like this. So we'll look at the Flutter rendering pipeline, custom render objects, what they are, when and why to use them, how to implement custom render objects. And then we'll look at a small demo. I'll take questions towards the end. It is my first time presenting this presentation, so please be indulgent. But if you have any questions, guys, also please don't hesitate to stop me. All right, so the first step we'll look at, before we get into the render object, let's look at, we have to understand like the Flutter rendering pipeline. So from user input to GPU instructions. So user interacts with the UI. Okay, animations will tick if there are any. We'll build then the widgets that you've described, right? So you have your configuration, your widgets. We'll instantiate those widgets. And these steps here, 4 and 5, are what we're specifically going to be interested in. 4 will be the layout, so positioning and sizing of the elements on your screen, painting those the layers for the elements, and then compositing these elements together. So what to know about painting and composition? One element can have multiple layers. So for example, if you think of a YouTube video with subtitles in front of it, right? So those are 2 separate layers to be painted in step number 5. And then composition will be bringing these 2 steps together into one final image to be displayed on your screen. So this process here that we looked at is the rendering pipeline, which happens in Flutter very fast. It has to be very efficient. And it happens on every frame, up to 60 times per second. So how does Flutter do it in an efficient way? You'll hear this term often in Flutter, the 3 trees. So what are the 3 trees in Flutter? We have the widget tree, the element tree, and the render object. There are more than 3 say that a couple times. There are more than 3 trees, but these are the core trees that we're going to look at. They're fundamental for rendering the UI efficiently. The widget tree is what we, as Flutter, when we write Flutter code, is what we actually create, right? So we'll create the code for a column, for a box, for a button, etc. So this is the configuration of what you want your UI to look like. It's a hierarchy of widgets, basically, and it's immutable. The element tree on the other end is the instantiation of these widgets that you've created. So this is long-lived, will persist across frames, and will handle the life cycle of the widgets and do the connection between the widget tree and the render object tree. The render object tree, finally, is responsible for creating the elements that you see on the UI, or the render objects that you see on the UI. So what we need to understand is that what you interact with, what you see on the UI, are actually render objects. So the render object tree is responsible for painting those UI elements, for sizing and positioning them, and also for defining and implementing hit testing for user interactions. Any questions so far? So this is the 3 trees. So we have here a widget tree, a very small widget tree with a container. Here is a row, and in this row there's an image and a text, those 2 widgets only. So this is the code that you've been writing in Flutter. Light blue here is the actual widget, and then you'll see those circle dots, those dotted circles here will be the actual elements that are created. So by that I mean that, for example, if you look at a text widget, us as developer, we just use the simple interface where we create text and then we provide whatever goes in there. Under the hood, it's creating a rich text widget, and the rich text is really what gets created and painted on the screen as a render paragraph. So this is really important because those widgets here, those widgets here create those elements, and those elements will in turn create these render objects. When you change, so if and when you change the UI, you want to do this in an efficient manner. The element tree is aware of, the element tree is capable of determining whether or not it can reuse the components that it has to optimize the rebuilding. So I'll give you a concrete example. If you look at a text widget that we have here, let's say it says, good morning. Now, through a user interaction, this changes to good evening. And so now the element tree will try to determine whether or not it has to rebuild. So this portion of the tree will be evaluated. It will say, am I able to reuse my current element that I have? And how it determines this is by looking at 2 things. It's going to look at the run type of your widget that you've created, and it's going to look at the key if you've provided one. So if you have a text and you're replacing it with another text, so good morning, and I think I said good evening, then the runtime is the same, text. The key, if you haven't provided one, is the same. So it says, yeah, I can reuse this render object element, and it's going to just update it. Okay, so this avoids the necessity of having to destroy and, let's say, rebuild part of the tree in this case. We're just going to update one variable. So that's why Flutter is very fast and it's able to optimize rebuildings and do this 60 times per second. Okay, so what are render objects? They're the core of the rendering process, the core building blocks of the rendering process, which I think I mentioned before. They handle layout, painting, and also hit testing. By hit testing, we mean interactions with those elements. If you ever looked at the widget tree, you'll see something like that under the widget tree. It's called render object, and you'll see it has information here, what constraints we've provided, and whether or not, like if we have a size, parent data, etc. So again, this is actually, the render object is actually what you are interacting with on the UI. So the common types of render objects that you'll see and use are render box to provide Cartesian coordinates, X and Y coordinates, and render sliver for lists, for example. There are more, but typically you'll use one of these 2. So why would you use a custom render object? There aren't a ton of use cases for custom render objects. You could write Flutter code all your life without having to ever implement a custom render object. But there are some cases that you can't do without. Some very complex layouts, custom hit testing, if you want to do fine grain control over painting, layout, sizing, etc. That's when custom render objects will be, a special tool in your tool set. So here on the, I have a small example here. This is from the package. It's called FL chart. Find it on PubDev. You can see that this chart, as you tap on certain points on the chart, it's going to give you this interactive tooltip, which is going to tell you what data is available at that point. Typically, something like this, you can't really accomplish out the box with typical columns and rows and typical Flutter widgets that are available to you. And this is because you want to have custom hit testing. So you want to say, if I tap here, this happened. Well, this is a single widget. Right? So this is one of the powerful things that you can do with custom render objects. Columns. So columns use custom render objects. So basically all the widgets that we use daily are implementation of custom render objects somewhere down the line, because everything is a render object. So columns, their render object is a render flex, and you can see that it uses it to calculate the main axis alignment. So here I said main axis alignment spaced evenly. I love Flutter for this. It's very simple to use. I provide a column, I say the size, and I say space them evenly, and it's nicely arranged. It calculates it does the math to what needs to be done for these two widgets to be spaced evenly among the space that's available within my column. How does it do that? Keep in mind that Flutter uses a single pass algorithm to build this tree. So at this point in time, I don't know the information about all my children. How can I position the children relative to each other without having all the information when it comes to their sizing and their positioning? So in order to do that, it uses the render flex, which is its custom render object. So I've kind of described the algorithm here, what it does under the hood, and there's a sequence diagram on the right. I'm just going to gloss over this, but essentially we are going to calculate the size of the column itself. So here I set the size at 1,000. We're going to calculate the size and constraint for all of the children, and then we're going to loop over each of the children, calculate its own size, and then use that to calculate where I'm going to position them amongst each other. Right? And this is done within the same frame, and that's why we're able to do to use something like space evenly or other main axis alignment parameters. Okay, so let's look at a basic implementation example. So an implementation example of a render box. So implementing a render object is really just implementing a few methods, at least for a basic example. You need to implement perform layout, where you define the size of your widget, and you will need to implement paint, where you actually paint what's on the screen. And then you can implement hit test if you need to. So here's an example. Constraints here is provided by the parent. So I can set the size to whatever I want. I can say size is equal to 100. So when it's laid out, the widget that I'm laying out will actually take this size here. So it's really important that in your perform layout, you actually declare the size of your widget, and then you do the painting of that widget itself. Here we're just drawing a rectangle. So that's it. This is the basic implementation of a custom render object. I omitted the hit test, but if you want, you can do some math here to calculate which portion of the widget has been clicked, and then return true or false based on whether or not you want to consider this an interaction with this widget or not. Next, you will implement the actual widget that you'll use in your tree on the right. Okay, so you'll name your widget. In this case, I call it custom widget. Extends one of the one of the render object widget subclasses. So single object, a single child render object widget is a widget that takes one child. You have the multi-child renderer object, which is like a column, for example, that takes many children. You have the leaf child renderer object, whichever you choose. Leaf is like the text widget, so it doesn't take any children. So in your create, and then you will implement create render object, in which you will return the render object that you've previously defined. So that said, these are the 3 steps for implementing the custom render object. Okay. I thought this was going to be much longer, so we will look at a quick demo. Are there any questions in the meantime?
I have a question. Can you launch the codes?
Oh, yes, the code, yes. Oh, I'm so sorry. Yeah, it's impossible to read. This is good?
Yes. It's better, thank you.
Fantastic, okay. Okay, so the actual output, I feel like you guys can hear me even if I'm not, yeah? Okay, so the actual output is this. So we have a circle and the widgets are laid out around the circle. So I'll press this button here. This is not what's supposed to happen. Just a sec here. Sorry about that. I will need just a second to revert my changes that I did just before. Don't want to do this on the recording. Give me just 1 second here. Technical difficulty. Sorry about that. All right, so while this is loading, should just be, oh, it's actually loaded, okay. Let's try again. Okay, that's the desired outcome. All right, so here's the desired outcome. So as you increase the number of children, they get laid out around the circle, and you can also resize the size of your children by using the slider. It's all nice and dandy. The interesting part as well is that when the children overlap each other, we want to draw a red box over them. So all this to say, you need to have information about the positioning and the size of all of the children in order to do something like that. And we'll look at how we can actually implement this. Yeah, feel free to stop me if you have any questions about the implementation. I'm not going to go too in depth, but I just want to highlight the big lines and give you a starting point if you're interested into exploring this for yourself. Okay, so we'll start by the main file. So in the main file, we'll have the typical widget tree, and this is the widget that I've defined. I called it a circle layout. So this circle layout takes a series of parameters. Nothing new here. This is just standard. So inside of the circle layout, we actually extend multi-child render widget. So I'm saying to Flutter, this will have multiple children. It's obviously, there are multiple children, more than one. So this is how we indicate to Flutter that we want to know about this. And it will automatically provide this children parameter here, which is the same for any multi-child renderer object that you've used, a list or, like a column or a row, for example. You can see that this widget here implements two things. One is the create, so I'm going to just return my circle layout, my render circle layout, excuse me, and I'm going to provide also an update method. So like if I do a set state or something like that, it's just going to update those parameters if it can reuse the same element. Okay, let's get to the good stuff. So we look at the render circle layout. Is it big enough? One more? Good. Fantastic. It's kind of hard to... Okay, so the render circle layout. So this is where we extend the render box. So by extending render box, I'm saying, hey, my widget is going to be inside of a box. Essentially what we're saying. Okay, so there's X and Y coordinates. We're providing also mix-in. This is just to help us with getting the children and helpful methods for that. So I'm passing all my parameters, the same parameters that I described in my widget. And here's the important part. There are two important methods. If you remember from my presentations, just a minute ago, was perform layout and then paint. Okay, so perform layout is the one that's responsible for setting the size of my box and setting the position and offset of each of the children, along with the size of each of the children, I should add here. And then painting, painting is exactly what it says, actually paints the widget on the screen. So if you don't implement these two, like if you don't implement paint, you won't have an error, but you just won't have anything to show on your screen. So within perform layout, I want to make sure that I use the setter to assign the size. Here I'm drawing a circle. I'm drawing a circle, so I'm just going to say the size is 2 times the radius that I've provided. And kind of gloss over. So here I'm providing the constraints for each of the children. So I can say the children can be as big as this. Each child can be as big as this box constraint. And then here's the loop. So if you remember the sequence diagram, there's a loop where in each of the iterations, we calculate the size of the child and we calculate the position of the child. I think I have it here. It's too small, eh? So each of the loop iteration, we will calculate the size of the child and then calculate the position of the child for each of the children. So this is happening in here. So the children is just a linked list. So we'll get the first element and then we'll loop over the elements of the list by calling next sibling. And then here, so for each of the child, you'll do layout. So this is computing the size. And then I have this, I'll save you the math, but essentially I'm doing some calculation based on this angle that I'm keeping track of to position the child. So basically setting the offset. And that's it for your layout. I've done my calculation of my parent size. I've done the calculation of each of the children's size, and I've also set the position of each of the children. Next, I will have to do the painting for each of the children. So the painting is typical, what you could do in a custom painter, for example. So again, the same concept, there's a linked list, so I'm going to iterate over all the children, and for each of the children, I'm just going to call paint child. So paint child is just saying, hey, children, do whatever is involved in painting yourself. So my container is just like just going to appear on the screen, and then set yourself at this position. This is the offset that I want this to appear on the screen. And I'm adding some extra logic here to also paint the overlap. This is the red box. Just give you a quick idea what that looks like. I have a list, and remember, this happens for every children. I have a list of the children that have already been painted. I will get their box, their rect, and I will see if the current child that I have is overlapping. There's a nice method that's provided by Flutter that's called overlaps, and I see if it overlaps with any of the other children, and if it does, I will draw a rectangle, a red rectangle around it, and I will fill in this rectangle with some red color as well. So that's the end result that you see here whenever there's an overlap. Okay, so that's what's involved. I'll share this code, and I'll share the slides as well. I invite you to take a look at this code and try to understand. And you'll see it can be some really, really powerful stuff that you can do with by implementing your own custom render objects here. Yeah, I believe that's it. I didn't implement hit testing, so we're not going to look at that. So any questions on the code before I'm going to start wrapping it up at this point? Okay.
Maybe I have one question.
Yeah, sorry.
In your demo, when you press the button, does it redraw all the boxes, or it only draw the box you need to draw?
That's a great question. So there's no, I didn't optimize for painting here. That's an excellent question. So it's actually going to redraw way too much in my case here. So a good optimization is to avoid repainting more than necessary. That's one thing that you can do. So if you were to look at, this is called, I forget what this is called, but it tells you where the drawing boxes are. And you can see that it's actually redrawing, everything. Right? So this part is getting redrawn every frame, and then this whole thing is getting redrawn every frame. So some optimizations, there's a lot of optimizations that you could and probably should do. The easiest one would be to use, it's called repaint boundaries. So for example, if I were to see this part here, I have a slider, I have this number thingy here at the bottom. So if I were to just wrap my slider inside of a repaint boundary, I would be able to save some computation power. So let's do it right now. So repaint boundary, and then this one here is a row as well. We'll wrap this in a repaint boundary. And then now, so you see the repaints now are optimized. So we're not rebuilding the slider every time I'm changing this number here. It's useless, right? And actually, I should put one around this circle box as well, but you get the general idea. So these are optimizations that you should probably do, especially as your UI gets more and more complex to prevent slower builds, if I could say. Answer your question? It's a great question. Okay, so that wraps up the demo. Again, I'll share the code. Feel free to look it up. And I will, just going to wrap it up. So essentially, as I presented, the custom render objects, useful for advanced layout, fine-grained control over painting, hit testing, the layout and the sizing and the positioning of your children. They enable performance optimization and custom user interactions like we saw in the example for charts. I recommend that you give it a try. If you're interested, start very small, like the example that I provided earlier, and then you can add more complex logic. I can think of charts. I can think of custom tables. I can think of there's a lot of things that you can do very efficiently if you were to implement this. Thank you very much. Yeah, sorry.
Can I think of the series of overrides that you're invoking as...
I'm sorry, can you say that again?
Can I think of the series of overrides that you're
Yeah.
invoking, can I think of them as a generator on the set of children that emerges, irrespective of number? Is that what your custom renders?
Does it generate the children, is what you're asking me?
Yes.
Does it generate the children?
Can I think of it as a generator?
It will call paint. So if you pass the children to, like, the column takes a set of children, right? And then the column will call paint, yes, on each of these children. So they will generate what you see on the screen in a way, yeah.
Okay, that's very interesting. So you have an automation process, but only on a specific set of permutations for n number of children. Is that fair enough?
Yes, I think, if I understand correctly the question, yes, I believe that is.
So where does it break down?
Where does it break
In
down?
what cases? Can you think of any specific cases?
Where it's not worth doing it, or was
Where
it?
the custom render would not assign the position and the size correctly?
I don't know if I can answer that right now. I can't think of.
Very well.
Yeah.
Maybe for future.
Yeah, I'll keep that in mind. That's a great question. You had a question as well?
Yes. We have for garbage collector for the list use list objects automatically.
Use list?
Yes, objects. When we create.
In which what part of Flutter you're referring to? For the what?
Render objects.
Uh-huh.
We have a system for the list use list objects.
Okay, he's asking how, because you're creating a lot of objects, right? So how does the garbage collector manage all the memory? Okay.
I'm sorry. Can you? I didn't understand. I'm sorry.
His concern is about memory. Like you're using a lot of objects every time you, I don't know, rendering everything.
Yeah.
How does the garbage collector manage all the instantiation in the memory?
We have a mechanism automatically.
So
To get rid of the elements once you're done?
Yeah.
If they're not used anymore, they will be marked detached or something like that. Yeah.
Basically, render also is also a wizard, right? So it's also part of the wizard life cycle.
Yeah.
When import happens, then it will free the memory.
Yeah, so if you look at this, for example, this here, right? So you have a row on the left. So let's say you change one of the children. The text, you don't have a text anymore, you only have an image. So this whole part of the tree will be destroyed. It's detached. So the next time you paint, it will say, oh, I don't have this children, I need to get rid of it.
I just wanted to know one thing. You mentioned something about the lake. So the children are in the lake.
Yeah.
Form of lake. So like if the children are in form of lake list, I believe that there is a point there is no breakout because even the lake list you can keep adding it up, right?
There is a point that there will be no what?
I mean, considering the question that he asked, like what's the point that it might break down, right?
Okay.
So how many number of children we can add to the lake list at which point it might break down? So how can a lake list break down? Because we can keep on adding it, right? It's not a regular array. It's a lake list. We can add it as long as our memory can hold it.
Yeah, essentially, as long as the memory can hold it. The whole app is a list of children, right? It's a tree, right? So we'll just add more elements in more and more to the tree. So you will not have, probably in most apps, you're not going to have like 20 or 50 elements. You're going to have like hundreds or thousands, right? It's just typical. So Flutter is built with that in mind, and that's where those 3 trees become very efficient in terms of, hey, I can get rid of this right branch, this subtree, and just rebuild this subtree, and I don't have to rebuild everything else in the tree. Time's up.